Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we have an isometric projection of a solid available with us, in which the front view, the top view and the side view of the solids, they are being projected into a single 3D drawing, and we are required to convert this isometric projection into the orthographic projection. So in the orthographic projections, we are required to draw three projections of the solid. That is, we are required to draw the front view, the top view and the left side views of this solid. And in order to draw the orthographic projections, we need to evaluate the sizes of the front view, top view and the side view of the solid. So in the front view, since we are able to witness the width of the solid and the height of the solid, so the dimensions of the front view should be, that is, the width is equal to 104 millimeter and the height of the solid is 48 millimeter. So the front view should measure 104 millimeter by 48 millimeter. Then in the top view, we are able to witness the width of the solid, which is equal to 104 millimeter, and the depth of the solid, which happens to be 72 millimeter. So the top view of this particular orthographic projection should be drawn as 104 millimeter by 72 millimeter. And finally the side view. So in the side view, we are able to get the depth of the solid, which is equal to 72 millimeter, and the height of the solid, which is equal to 48 millimeter. So the side view dimensions of the solid, they are 72 millimeter by 48 millimeter, right? So we have worked out that what will be the dimensions of the front view, top view and the side view in the orthographic construction. Now let us see, when we are going to view the solid from the front view, from the front side, from the top view and from the left side view, what are the surfaces which we are going to obtain while viewing these solids from these three orientation. So the first one, we have the surfaces A, B and C. These three surfaces, they will be visible to us while we are going to look at this particular solid from the front side. Similarly, when we are looking at the solid from the top side, that is from above, then the surfaces 1, 2 and 3 will be visible. And when we are going to look at the solid from the side, so this is surface X, it is this surface, and then the second surface will be surface Y over here, right? So these are the two surfaces which will be visible to us from the side view. So we have used different color codings for these surfaces. So let us start with surfaces of the front view. So the first surface of the front view is the surface A, which is the vertical surface of the first step from the top, and this is a rectangular surface, and the true shape of this surface will be obtained on the vertical plane. Similarly, you have the surface B, which is again a rectangular surface, and this is the vertical portion of the second step. So this is my second step. So this is a stepped solid. So corresponding to the second step, this is going to be the vertical portion over here. So this portion has been labeled as surface B. And then you have the surface C, which is an angular surface. You can check, this is an angular surface, and corresponding to this surface C, once again the projections of this surface C will be obtained on the vertical plane, and the projections of surface A, surface B and surface C, as they are obtained on the vertical plane, they will provide us the true shapes of surfaces A, B and C, since these surfaces, they happen to be parallel to the vertical plane. Now let us talk about the surfaces which will be obtained while we are going to look at the solid from the top side, that is when we are looking at the solid from above. Then these surfaces, they happen to be surface 1, 2 and 3. So surface 1, it is angular 1, and once again we are going to get true shape of this angular 1 surface in the top view. Then you have the surface 2, this is the horizontal portion of the second step. Again it is a rectangular portion and true shape will be obtained on the horizontal plane. And finally you have the surface 3. Again this is a rectangular surface and true shape of this surface will also be obtained on HP, because these surfaces 1, 2 and 3, so they are parallel to the horizontal plane. And once you are looking at the solid from the left hand side, so this is first step surface which is visible from the side. This is called surface X. Okay, so this is the stepped surface. So the true shape of this surface will also be obtained on the profile plane, because this surface X happens to be parallel to the profile plane. And finally you have the surface Y. This is again a vertical surface and this is being parallel to the profile plane. So the true shape of the surface Y will be visible in the profile plane, right? So this is the discussion regarding these surfaces which will be visible to us in the three views over there. So let us start with the construction of the orthographic projection. So here we have the XY line and the X1 Y1 line. So here we are going to get the front view of these orthographic projections. This will be drawn on this side. This is my vertical plane. The top view will be drawn over here and the left hand side view will be drawn on the right hand side of the front view. So this is the location of the front view, location of the top view and the location of the left hand side view. So now we know that what are the dimensions of the front face. The front face is going to reveal the width and the height of the solid. So let us mark the width. So the width of the solid is equal to 104 millimeter. So we have marked it over here. And then next the height of the solid, this is equal to 48 millimeter. Now this is the basic construction for the front view, right? So within this block I am going to locate the construction of the front view, and this horizontal line which is corresponding to the height of the solid, so this will be projected along the left side view also, because in the left side view again the height of the solid has to be produced over there. Similarly the width dimensions, they will be projected onto the top view surface also, because onto the top view also the width of the solid will be visible to us. And the depth of the solid, you can check, the depth of the solid is equal to 72 millimeter. So this is the width of the solid which is equal to 104 millimeter. So please check, for the top view my outer block construction will be having the dimensions 104 millimeter is the width and 72 millimeter is the depth of the solid over there. Then corresponding to the side view also, please check, this is going to be my depth of the solid. So this depth of the solid has been transferred from the top view. So we can say that this left hand side view, it is drawn from the dimensions which are coming from the front view and which are available with us from the top view of this particular orthographic construction. So this width of the solid we have drawn as 72 millimeter, which is again transferred from this top view. Similarly this height of the solid which is 48 millimeter, so this is coming from the front view. So separate dimensioning we need not do, but just for the purpose of identification we have marked that this dimension is the depth and this dimension represents the height of the solid. So later on we are going to remove these dimensions because they are no longer required otherwise, right? This is only for the purpose of explanation. Now as we can see that this is a solid in which there are three steps, and along the depth, please check, along the depth of the solid which measures 72 millimeter. So each element, there are three steps over there, and each element in the three steps, it is having dimension equal to 24 millimeter horizontally. So along this particular side you are going to have this edge length is equal to 24 millimeter. So as we are going to look from the top, we will see that, please check, here you have 24, 24 and 24. So these are going to mark three steps orientation over there. So since we have marked them along the depth in the top view, so the same dimension they have been transferred on the left hand side view. If we are going to look at the solid from left hand side, please check corresponding to surface X, this has to be 24 millimeter, this length has to be 24 millimeter, and this length has to be 24 millimeter. Similarly, along this height which is equal to 48 millimeter, so since we have got 3 steps, so the vertical component of these 3 steps, that is each element of these 3 steps, again it is equally distributed, that is 16 millimeter. So 16 millimeter, it is the height of the first step, and similarly 16 millimeter, it is the height of the second step, and the 16 millimeter is your height of the third step. So these 3 heights, they will be visible to us in the front view as well as in the left side view. Now please check, I have marked first step from the top 16 millimeter, second step from the top 16. So I have marked first step 16 millimeter, second step 16 millimeter, third step 16 I need not show because I have already shown the total height of the solid, it is equal to 48. So since the height of 2 elements I have shown over here, so automatically the third element, that is this C element over here, so the height of this element will automatically be 16 millimeter. So I am going to draw, please check, 2 horizontal projection lines through these points over there, where I had identified that these are the heights of the element number 1, which is A, and the element number B over here. This is my element number 2. So I have got the basic construction completed over there. Then the last one, I need to draw the width of this section, because this is an angular section. Section C was an angular section. So in this angular section, the horizontal component of this angular section, this was having the height is equal to 16 millimeter, and this length of the section, that is flat section, this was 104 minus 24, that is 80 millimeter. So this horizontal section is measuring 80 millimeter over there. That is these 3 steps, step 1, 2, 3 over here. So this length will be 80 millimeter, and this length of this angular section C, it happens to be how much? 24 millimeter. So I have marked this width over here as 24 millimeter and drawn a projection line starting from the front view, and it will be moving on to the top view. Why? Because the top view surface 1, this is width 24, again this is width 24. So this angular section will be having a uniform width of 24 millimeter over there, right? So let us start with now the construction of the front view. So in the front view, please check, the boundary will be visible. So I have drawn the boundary as blue color over there, because I can see this is the outer boundary of the solid which will be visible to me, right? So this line and this line, they will appearing in the same horizontal plane over there, right? In the same area they are going to be seen. Why? Because this is also parallel to VP, this is also parallel to VP. So on the vertical plane, because this surface happens to be perpendicular to VP, so this H and this H, they will be coinciding in the front view. So outer box we have drawn. Now in the front view we have got 3 sections over there. First surface corresponding to the first element over here, this is measuring 80 millimeter by 16 millimeter. Surface B is going to measure 80 millimeter by 16 millimeter, and then you have the surface C, which is an integral surface. So first element of the surface C will measure 80 by 16, and the second element will be measuring over here, please check, 48 by 24. So if I am going to join these surfaces, please see I have drawn these 2 lines over here. Now this is the surface A, which I am able to see from this portion. This is my surface B, 80 millimeter by 16 millimeter, and this one 16 by 80 is the element number 1 of surface C. This is element 1 of surface C, and then the element 2 of surface C is this one. 24 is the width and 48 is the height. And since this surface is integral, so no boundary line will be joined over here. It is an integral angular surface. Now let us mark the surfaces: surface A, surface B and surface C. And it must be remembered that we are going to witness the true shapes of the surfaces A, B and C onto the vertical plane, because these three surfaces A, B and C, they happen to be parallel to the vertical plane. Now let us work out the top view. In the top view, please check, we have got element number 1. This is having an angular shape. So the width of this is 24 millimeter throughout. And then we have two more sections over there, surface 2 and surface 3. So surface 2 is going to have the dimension 24 millimeter by 24 millimeter. This is going to be rectangle. Again, surface 3 will be rectangle having the dimensions equal to 24 millimeter by 80 millimeter, right? So all these three surfaces, surface 1, surface 2 and surface 3, they are viewed and they are observed as true shapes onto the top view in the horizontal plane, because the surfaces 1, 2 and 3, they happen to be parallel to the horizontal plane. So let us mark these surfaces. Surface 1, so this is, please check, an angular shaped surface having uniform width equal to 24. So this is also 24, this is also 24. So this I haven't marked 24 here because this was already marked as 24 in the front view. So need not repeat the dimensions everywhere, right? So 24 width has been marked over here. So same width will be drawn in the top view as well. So this is surface 2, 80 millimeter is the length, 24 millimeter is the width over here or the depth over here. Similarly, this is surface 3 having depth equal to 24 and the length will be 80 millimeter. So this is the construction of the top view. Now let us work out the side view. In the side view, we are going to have this surface X over here, which is a stepped surface, right? So this is also a true shape, and this surface Y, this is also a true shape. This is again an angular surface over here. So now the boundary will be visible. Why? Because this portion I can already see, whereas the remaining portion, it is appearing from the back side wall of this particular surface. So this edge and this edge, they happen to be parallel to the profile plane. So since they are parallel to the profile plane and this surface is perpendicular to the profile plane, so the projection of this surface will be appearing as a straight line without any break. That is why this line or edge has been joined, whereas this is the edge corresponding to the surface X and this is the edge corresponding to the surface Y over here, right? So now we draw the steps over here. So the first step is 16 millimeter down, 24 millimeter again moving towards the front side. So 16 millimeter down, this is visible from the front view also, and then 24 millimeter towards the front edge over here. Then again you move 16 millimeter down and 24 millimeter towards the front surface. And now this is going to be my surface X and this is going to be my surface Y. And please check, these dimensions, they were repeating over here because they were already drawn in the top view. So there should not be any redundancy regarding the dimensioning. So just for the purpose of understanding, we had drawn these dimensions while we had started construction of the orthographic projection. But in order to complete this construction, we do not need these dimensions. So that is why we have removed these dimensions from the final view. Now this is going to be my surface X. This is going to be my surface Y. Over here, this is my surface Y. And both of these surfaces X and Y, they are true shapes which are projected onto the profile plane. So I'll have my profile plane over here and X and Y surfaces, because they are the left side views, so they have been projected onto the profile plane, right? So these are the projections of the solid whose isometric projection was available with us. Now in the final construction, in order to have a better clarity, Now I am going to remove these surfaces from the original picture as well as from the isometric construction. So this is the complete description about the development of the orthographic projections when the isometric projections or the 3D projection of a solid is available with us. So I hope through this discussion you would have developed a proper understanding how we can convert a 3D projection into a 2D orthographic or a multi-view projection. So here we have developed the left side view, then the front view and the top view of a solid. So this is all for today. Thank you very much. Thanks a lot.